My name is Mary Sevart. I am a junior in chemical engineering, and I'm from Wichita, Kansas. Today I'll be talking about my undergraduate research, and specifically my project is how I convert hemp biomass into a usable fuel source. So how did I get involved in undergraduate research? So I started out my freshman year taking CMPE 111, Intro to Chemical Engineering with Dr. Williams. And part of this course was a lab portion where we got to synthesize biodiesel in the lab. It was a very hands-on activity. It was really exciting and truly ignited my passion for chemical engineering. After taking this course, I realized that I wanted to do research similar to how I did in this introduction class. So I emailed many different professors, and I actually decided on joining Dr. Williams's lab, the KU Biodiesel Initiative. I currently work in testing for that lab. We create biodiesel on a large scale rather than the small scale we did in the lab, and we sell it to facilities on campus. So, after working with the KU Biodiesel Initiative for about a year, I reached out to Dr. Williams to start doing research. And she mentioned this really cool project that she had just started that I got to start with her. So, what exactly is my project? So, currently, CBD oil is growing in popularity around the United States. You can use it to help treat anxiety, insomnia, and countless other things. There's three common methods to extract CBD oil from the stalks, leaves, and flowers of the hemp plant. Two of the most common ones are solvent extraction and supercritical CO2 extraction. So solvent extraction usually uses hexane. You put the stalks, leaves, and flowers in a basin and you add hexane and you heat it up and it extracts it, the CBD oil. Supercritical CO2 extraction works very similarly, except you're using carbon dioxide instead. And a less common method for extracting the CBD oil is ice water. After this extraction, the stalks, leaves, and flowers are still left, but right now they are landfilled and currently viewed as waste products. So thousands of pounds of this hemp biomass is landfilled every year, as evidenced by this picture. And we would love to be able to turn this hemp biomass into something useful and profitable for our farmers. So my research uses thermochemical processing, specifically hydrothermal liquefaction, which is a big long word to mean that it mimics fossil fuel production in the lab. So we take hemp biomass and we add a little bit of water in a 450 milliliter reactor. We close it up really tight so that there's no leaks, and we heat it up. And these high temperatures create high pressure within the vessel, and this mimics fossil fuel production, like what happens geologically over millions of years, except this reaction only takes a few hours. It's pretty new, and right now it has only been used with algae as the feedstock instead of hemp biomass. This is really exciting because we don't have any previous research to base our current research off of. It has its positivity parts and its challenges, definitely. But I think it's really exciting to get to spearhead an independent project over something that has never been done before. So, what is next for our research? This next semester, we're going to start reactions. Currently, we've been getting our reaction vessel online, and we're going to start characterization of our hemp biomass. So that way we have a standard to base everything off of after we analyze it after reactions. We're going to continue doing literature review to make sure that we're up to date on current research, to make sure no one else is doing a similar project. And then we're also going to start working on a rough draft of our paper since we're on track to publish this next year, which is really exciting. I am beyond excited to get to meet all of you and to talk more about my research and my experiences at KU.